This video will cover number 6, or proof number 3 on our Chapter 2 review, and then 7 through 13 on our Chapter 2 review. All right, so in number 6, we are given that angle 2 is congruent to angle 3. Okay, I'm going to put that in my picture with arcs, and then put that as my first statement. And we're trying to prove that angle 4 is congruent to angle 1. So I'm going to put that at the end. I don't know the reason for that yet, though. All right, if I'm looking here, angle 1 is congruent to angle 2. If I look at my picture, how do we know that? Well, I know angle 1 and angle 2 are congruent because these form a pair of vertical angles, right? And by the vertical angles theorem, we know that vertical angles are congruent. All right, so now I know for statement 3, I'm going to be using the substitution property. So I have to go up above and think, okay, well, what's my only option? What can I substitute in for something else? Okay. So I know, okay, angle 2 is congruent to angle 3. So I could take angle 3 and substitute it into the second congruent statement in for angle 2. When I do that, I'm left with angle 1 is congruent to angle 3. All right, so now I'm moving on to statement 4, and we know, okay, angle 3 is congruent to angle 4. In my picture, how do I know that? Well, again, angle 3 and 4 are another pair of vertical angles. So by the vertical angles theorem, I know they're congruent. And lastly, how am I going to conclude then that angle 4 is congruent to angle 1? Well, if I look up at my two statements here, angle 1 is congruent to angle 3, and angle 3 is also congruent to angle 4. So if angle 3 is congruent to both angle 1 and angle 4, then I know these two must also be congruent to each other. Right? So when I use two congruent statements to come up with my third, I'm using the transitive property. Or again, you could think of this as using substitution. Right? You can imagine taking angle 1 here and substituting it in for angle 3 to get that angle 1 is congruent to angle 4. Now, these look different, but they're the same thing, right? Because by the symmetric property, we can flip these. We probably really should have an extra step in here using the symmetric property to go from here to here, but for now, we'll just call it okay. So we're going to put substitution. All right, let's go through 7 through 13 and just go ahead and name the properties of each statement. If LM equals RS and RS equals 25, then LM equals 25. This is set up similar to if A equals B and B equals C, then A equals C. This is a transitive property. You could have also thought of it as substitution, right? You could have thought of taking LM and substituting it in for RS to get your final equation. Eight, AM equals AM. This is something equals itself, right? A equals A. That is the reflexive property. If angle DEF is congruent to angle JKL, then angle JKL is congruent to angle DEF. All that's happening here is we're taking our congruent statement and we're flipping it, right? If A equals B, then B equals A. When we flip it, that is the symmetric property. Angle C is congruent to itself. It's the same thing on both sides. That's another reflexive property. If MN equals PQ and PQ equals RS, then MN equals RS. Just like in number 7, this is in the form, if A equals B and B equals C, then A equals C. That's transitive or substitution. If x equals 4 and y equals negative 2x minus 3, then y equals negative 2 times 4 minus 3. All right, in number 12, I want to look at my two equations here and think about what's happening to go from here, these two equations, to my final equation. Well, what I notice is the difference between this equation and this equation is there's a 4 plugged in here for x. So why can we do that? Well, look, x equals 4. So if x equals 4, we can take 4 and plug it in or substitute it in for x. And when we do that, this is what we're left with. 4 is in the place of x. That is the substitution property. If xy equals rt, then 3xy equals 3rt. Ask yourself, what's different from these two equations? I have this extra 3 out here. This is 3 times xy and 3 times rt. All we're doing differently is we're taking this equation and we're multiplying both sides by 3. If you multiply an equation by something on both sides, you're using the multiplication property. Right? I can see that multiplication happening.